All right, so here we have the formal definition of a limit. So before I dig into this notation, I'm going to tell you a little story. I'll end up erasing this, but I think it is helpful. All right. So I had an 84-year-old neighbor who would walk along the sidewalk. And here was all of my grass. And then here was the grass on that little boulevard. And I had some flowers growing out here too. Okay, so I came from my house and I would have the hose and I would water here and I would take the hose across the sidewalk and water over here. So I would not want to get water on the sidewalk because when Gloria walked by with her walker, I did not want to get it here. Okay, so this was the especially hard part to water. So what I did is I would adjust the nozzle. So I would look to where I was going and I would adjust the nozzle. So thinking back to the water, thinking back to the domain as it were, thinking where I want to go so I stay in this range. So it's always looking back and looking forward to where I want to go. All right, so I'm going to translate that into our limit. Okay, so what we're doing is we're finding a formal definition for this limit. So let's just get a picture going here so you know something like this. That's our f of x. We know that a is always on the x-axis, right? And then here, if there is a limit, which it says it is, then if I take the limit as x goes towards a from both sides, right, that gives me the y value of L. Okay, so this is the picture that goes with limit as x goes towards a of f of x equals L. Okay, so what we're going to do is we're going to talk about a formal definition. So we're going to make an epsilon. So the epsilon I'm going to make on neighborhood on the y-axis. So if I add epsilon to L, I get L plus epsilon. And if I subtract epsilon from L, I get L minus epsilon. So this I'm going to call the epsilon neighborhood. So you can kind of think of that as where I want to go, where I want to water. So given, if I have a number epsilon, and it's always going to be a small positive number, very small positive number, then what I need to do is I need to find a delta. And where the delta is on the x-axis. So this x minus, absolute value of x minus a is less than delta is bigger than 0. Bigger than 0 means you can't have delta equal 0, right? Delta cannot equal 0, so delta is some small positive number, right? And so what it's saying is that there's going to be a delta neighborhood, add delta, subtract delta. So this would be a plus delta, this would be a minus delta. So the logic is that if I stay this close to the A, then when I jump on the graph and I go up to the function, I stay in this region. So your job will always be to find delta. So find the delta. What is that distance delta? And again, it's going to be a small positive distance. What is that distance delta, so that if I move that far away in either direction from the A, then I jump on the graph, do I stay inside the epsilon neighborhood? So find delta so that if I stay that far away from the A, this would be the A, right? Then I stay in your epsilon neighborhood. So they're telling us here the epsilon is 0.1. All right, so let's dig in to this example. So let me erase this because we don't need this anymore. So let me keep the picture, what I had before, and let's put our numbers in. So first we need to decode what we're being given. So you really do have to be familiar with the definition. So kind of looking up here. So this is this. So comparing those two, that tells me that A equal 2. All right, so now let's compare this. This and this. This is telling me that the epsilon is 0.1. that the f of x is x cubed and the a is, I'm sorry, 8. Not the a, the l, sorry about that. The l is 8, right? F of x minus l and epsilon. Okay, so we should be able to rewrite this as a limit statement. Limit as x goes to a of f of x equal L, right? So let's just fill it in. Limit as x goes to 2 of x cubed equal 8. Yes, that's true. It should make sense. It should work, right? Okay, so let's draw a picture of what I've got. So here would be number 2. A is 2 is on the x-axis. So the function is f of x equal x cubed. And the L, right, if I take x cubed and 2 cubed, that gives me 8 on this axis. Okay, so that's the picture. It's always helpful to get a picture going. So then what you want to do is you want to make your epsilon neighborhood. So your epsilon is 0.1. So you want to move up by 0.1 on the y-axis and want to subtract 0.1 on the y-axis. Okay, so I want to stay inside here. So now what I'm going to do is I'm going to work these backwards to find out what these x values, oops, that wasn't a very good picture. So what I'm trying to do is say this one goes to this, right? And they'll be different, right? So I want to find out what these x values are. So you know, to get from 8 to 2, I would take the cube root, right? So this is the cube root of 8. So to get from 8.1 to what this x value will be, oh, let me just erase it, will be the cube root of 8.1. Then to go backwards from here, to take the 7.9 and find out what it comes back to on the x-axis, this will be the cube root of 7.9. Okay. So now what we need to find is the distance. So the distance delta are this distance here and this distance here. So they're gonna be different because I've got a curved function. So I'm just gonna label it delta 1 and delta 2. So delta 1, and I'm just gonna subtract them in the order so I get a positive number. So I'm gonna say 2 subtract the cube root of 7.9. So 2 subtract this, that gives me delta 1 distance. This is delta 2, right? Delta 2, sorry, that's kind of messy. So delta 2 is this distance over here. So I'm going to subtract them in the order so I get a positive distance. So I get a cube root of 8.1 subtract 2. Okay, so now it's my job to go figure out what those decimals are. So you should know how to find the cube root, right? So that's to the 1/3 power. So 2 minus, and I'm going to put parentheses 7.9, parentheses to the 1/3 power. Okay, and you should have your calculator set to at least 6 decimal places. So this gives me a decimal place of 0.08368. That's 1, 2, 3, 4, 5, 6 decimal places. This is good. Okay, so then I want to find this subtraction. So I want to say the cube root of 8.1, and I'm going to subtract off 2, and this gives me, let me put it down here, 0.0082988. Okay, so now I need to choose which one will work. So what am I talking about? So this distance here, this delta 1 distance is larger, right? So this is the larger distance. So if I go this distance in this direction, for sure, I end up in my epsilon neighborhood. It's all good, right? Okay. But over here, this is a smaller distance, right? So this black distance, if I use this one, would go all the way over to here. Oh no, I would not be in the epsilon neighborhood. So I have to choose the smaller of the 2 deltas. So therefore, the delta that will work will be 0.0082988.